Hello, my name is Gaia, and this year I'm presenting a poster at EGU in Vienna. This research is part of my PhD project at the University of Bristol in collaboration with Fathom and focuses on global stochastic flood modelling, more specifically on how global hydrological models can help us developing large-scale stochastic models in data-scarce regions. So, stochastic flood models allow us to simulate realistic flood events. Instead of simulating static hazard maps with a certain return period everywhere in the study area, we can generate large ensembles of flood events with a realistic spatial structure, which is very useful for loss calculations. These models typically derive the spatial dependency from historical data and are therefore not applicable in data-scarce regions. This is why we have been testing a new approach that is based on global hydrological models and uses global rainfall and discharge reanalysis to derive spatial correlation. You can see a schematic of this process on the bottom left of my poster, summarizing how rainfall and discharge data from global hydrological models are the input to the stochastic model that derives the spatial correlation and then uses it to simulate a flood event set. In my first PhD chapter, we tested this approach globally by comparing it to a gauge-based method, wherever gauge data was available. The results from these tests were promising, and you can find out more about it in the latest paper we published in Water Resources Research. You can see the title highlighted in the yellow box on the right of my poster. So this led to the second phase of the project, where we chose a test case to evaluate more accurately the flood events generated by this methodology. We chose Southeast Asia since it is one of the regions with more exposure to flooding, predominantly caused by monsoons, tropical cyclones, and heavy rains. Southeast Asia doesn't have a dense network of river gauges or long stream flow records, and it is therefore not possible to rely on measured data to drive stochastic simulations in this region. We chose to generate both fluvial and pluvial events and use the most recent GLOFOS river discharge reanalysis and ERA5 as inputs to the model. We've been then analyzing the outputs of the model by comparing them to historical events, and the results so far show that most events represent well the effect of physically plausible phenomena, such as tropical cyclones, monsoon systems, or convective storms. And you can see two examples of events generated by our model in the central part of the poster. Currently, we're working on calculating the exposure to flood risk in the region, and we will look into calculating economic losses in the future. The results so far are very promising in the context of stochastic modeling and consolidate our conclusions that using hydrological models can allow us to generate flood event sets in data-scarce regions. To know more about this, you can come chat to me at EGU on Friday morning or send me an email.